Welcome to the Geometry Nodes Beginners course. In this video, I want to talk about colors and how to apply or assign materials to the geometry and a little excursus to the attributes, which is connected to the materials. Alright, before we can assign a material, let's just create one. In the Materials tab, we got something here, so let's call this material red and change its base color to red here. Alright, now let's open the Geometry Nodes editor and create a new group. Alright, so let's detach the geometry input here to create a procedural geometry. For example, a cube, which I can connect then to the output. Alright, now we got a cube here in the tree. Now how to assign a material to it. So at first let me switch to the material preview that we can actually see the materials. So currently it has no material, so it's displayed as white. And to assign something, you just have to use a material node, which is the set material. Here, set material. Then connect it in between here. And now you have a material slot here. Just like here, you can click on it and just select the red material. And as you can see now, you assigned this red material to the cube. So let's just make a copy of this and create a blue material, for example, and make a copy of that too, and create a green material. All right, now we have 3 different materials and you can select them here as well. Red, green, blue. You can switch at any time from one material to another. Alright, now this is for a single geometry case here, but what about when you have multiple pieces of geometry? Let's go through that as well. So at first, let's create some more geometry here. So for now, let me just delete that and use a, let's say, a UV sphere and a cone as well. And then, connect them with a join geometry node here to the same path. All right. So now I got this. Let's put that away. And I want to have a transform node as well for every individual so that I can, control each of them individually. So here, now I want to move some of them to the side that we can see them parallelly like this, and the cone maybe a bit down. Alright, now we got our 3 pieces of geometry here. So now about the materials, you have to imagine it as, here the paths of the individual geometry, and you join them, and then you have this combined geometry here to assign the materials. Because if you assign the material here, for example, so let's just do that, set material with red, for example, everything will become red, because the geometry path here is combined to the same geometry, and then you assign a red to it. Now let's put that here, for example, the red one on the cube before you combine it. Then you only set the cube to red, for example. And then let's copy that in here for the UV sphere. So for the ball, this will get blue, for example, because you have this isolated material here, and then you combine these different materials. And when you set this here to green, you can have these isolated pieces of geometry with their individual color, and then you mix it after that, and then they will have their own color here. But you can override all of them when you just change the material here again to, let's say, blue. And you can override that if you change it here to red. So you can see the last material input for the geometry piece, in this case, every one of them, you can override it by just using another node here. So the last material node counts in this case. So, but if you want to have it like this, you can just assign it before you join them, and then you will have their individual materials assigned to them. Alright, so this was the simple part of the material assignment, where you just basically put one node in between and then you have your material. Let's switch to a bit more complicated part, where you assign certain points to a attribute, and by this you can influence their material, for example. So let me just delete some things here because I only need the UV sphere here. So we can delete these parts like this. So now I have my UV sphere only in the center here. All right. So at first, let me tell you a little bit about attributes. For that, I have to open a new window, which is the spreadsheet, where you can see all the attributes of your points, basically on your objects, for example, on the geometry. Here on my UV sphere, where I haven't done anything, I have basically only one attribute, which is the position of every point on this UV sphere. Yeah, it's pretty much, I have 482 points, yeah, because 481 is the last one and the first one is 0. So I have, you can see it here, 482 vertices or points on my sphere here. And yeah, every position has 3 values, which is the X, Y, and Z value. And yeah, by this you have your attribute displayed as 3 values. But I can add another attribute to these points. So for example, I want to use a noise texture, which I showed you in a video before, where you have noise values in the world. And for example, on this point here, if a point would be there, it would have this value of this noise field here, or this noise texture. And I can read the noise value on the point position by just creating a noise texture. Let's do that. Noise texture. And then, for example, let's just portray it here with a viewer node. With a viewer node, you can see values on points, basically. So let's connect the geometry I want to look at, and then connect the values I want to look at. And then I want to, let's enable that here. And then it switches here to viewer node, and now you can see what the viewer sees. So basically I can see the geometry just as usual. And now I see the added values here, which is here on the viewer side. And when I now change the scale, for example, of the noise texture, you can see that the viewer values here change, because this is now the noise texture value basically on the point. You can see here, for example, now my vertex 10, the vertex with the index 10, which is the 11th vertex, has 0.367 as the noise value. When I change the noise field and make it bigger or something, then I change the value of it. And you can actually see it in Blender version 3.4. From that on, you can see what the viewer sees. Beforehand you couldn't see it on the model itself, but on 3.4 you can see the actual values, and you can see the noise texture if I'm decreasing it now to a pretty small point here. So you can see this fog here basically. So for example, this point here, or maybe let me enable the wireframe, you can see it. So for example, this point here has a rather low, or this point here has a rather low value, I don't know, maybe 0.2 or something. That's why it's pretty dark here. This point here has a low value as well, because here's a line between them, which means it's interpolating from a low value to another low value. That's why you have this line here. And this is a higher value. You can see that because here's a contrast between dark and bright and so on. So here you can actually see the values of this noise field. And we can use this information now to, let's say, mix a material or something like that. So let me disable this wireframe. So here you have your visual representation of the values. In the viewer, you have this list of values, and the noise texture just gives you these values basically, like this, for example. And of course, you can just use a color ramp to give it more contrast to see it better. So let's make this more contrasty like this. Now you can see the values pretty well. High value, very low value, and mid value. So this could be a 1, this could be a 0.5, and this could be a 0, for example. So, and this is how the values are displayed and written. So in order to see the actual values, or to use them, you have to connect it to the group output, basically this one here. So now you have because what the viewer sees, you can't use this data. You can delete it and it's no difference. It's just for you that you can see what you're doing. But what's important is the group output. So currently I have a geometry output like normal. Yeah, if I would delete it, there would be no geometry. And I have my color ramp output here, which is a color output. And let me go back to the geometry nodes. And here now we have our output attributes now, which is this one here. And you can change it when you press N or open this menu here manually. And then you have to go to group and here is your output. Yeah, currently it's a color, but I could, for example, exchange that to a float because it basically makes no difference since it's only gray values. So it's basically a float value anyway. And I could rename it. For example, I could call this noise and now I have noise here. In this case, it doesn't matter, but if I have, let's say, 20 different output attributes, I maybe want to rename them that I get an overview about them. Alright, and now I have to give this attribute a name. This is very important because you have to reference this name later on. Yeah, for example, we could name this, let's say, noise value. Alright, and now you can see, now my geometry got the position value and now a noise value, which is exactly this list of values for every point here. Alright, and now we just wrote these values on the points and we can use them now. So let's switch here back to the shader editor. And this is our material. And we could now use the attribute. By the way, you can see here's a green color, but my object isn't green. Why is that so? Well, that's because, let's go back, I haven't assigned any material here yet. Yeah, I deleted it before. So you could just use a set material and just add anything. Let's say we want to use the red one and then switch back to the shader editor. And then I want to edit the red one. Now I'm on the correct side. All right, now let's use a node in the shader editor, which is the attribute node. With this node, you can access attributes. So the attribute I want to access is my noise value here from the output of the geometry nodes. That's why I want to type in here my value, noise value. That's the attribute I want to pull out here. And let's say I want to use the factor for the color. And there you have it. Now my values here are the actual color now of my principled BSDF input. So it's the base color of the object here. Maybe we could make this a bit more smooth. So let's go to the geometry nodes editor and maybe make a set shade smooth at the end. So we have here this smooth shading. And then we may want to increase the poly count here a bit. So we could use a subdivision surface to just subdivide it a couple of times to get more smooth values here. So let's divide it 4 times, for example, and then we have pretty smooth values here, but it will increase the point count as well. You can see that this is the original one, and this is now the subdivided, but you can see the noise values are very, very more precise. So, of course, more precision on the points here is, of course, more details. Since, the attributes values are written on the point, so every point is one value change. So let's go back to the shader editor. And now we have here the factor, but we can change it for everything else. So let's say I want to use the factor for the roughness, for example. And now you can see what's happening here. Now I have some glossy areas like here, and I have some rough areas like here. Yeah, so now this is basically a roughness map for my sphere here. Just the values on the sphere before, the noise map, the noise texture, is now a roughness map for my principled BSDF. So we just used the values of the noise value attribute on the points to define something, in this case, a roughness value. So as you can see, you can play around very, very much with the values. And since we got some values now, so we can do anything we want with it. That's just the case here. You just have to gather some values and then you can do everything you want to. Alright, so let's just do something else with it. We could mix the color, for example, too. So in this case, or for now we have only one color, but we could use a mix RGB. So we just use a mix node on color. All right, and then we want to, let's say, want to mix a red color with a blue color, and for the mixing factor, so let's connect that here. For the mixing factor, I don't want to use this slider here, but this factor like that. And now my glossy areas are red and my non-glossy areas are blue. For example, you could do something like this as well. All right, now I want to do one last thing. So for that, I just go back to the geometry nodes editor and maybe change this a bit. I don't have that many blue spots here, like this, for example. Yeah, that's fine. And now I could use these values, since I already got them, I could use it to displace these areas here outwards. For example, because the values are the same and it's synchronized, then I could use the noise value here to just multiply the normal vector with it. Which means here, for example, it would be 0, here would be 0, here would be 0. Let's say here it would be around 0.5. And here it would be around 1, which means it would create a bump here, basically, like this. And on every blue spot. And by this you can create a procedural displacement map on exactly the colored spots here, since they share exactly the same data. Or let's say the same values on the points, in this case the noise value attribute. So to do that, let me just move the things here a bit. So I want to use a set position, because we want to move points, and you do this with the set position node. And I want to move the points along their normal. So that's why I want to use a normal node here with a normal vector output. And I want to multiply these values with the basically output of the color here. Because here it's a grayscale, so only the values from 0 to 1, on one dimension basically come out of this output. So I want to multiply this value with this scalar here then, and then I get my result. So to do that, I want to use a vector math node. Here, let's move this a bit. So the result should be in the offset. And I want to multiply. Here, multiply, normal, multiplied by this scalar. And then you have something like this. I mean, this is pretty hard. So let's move this a bit, and we want to put something in between here maybe. For example, a math node on multiply, where we can adjust the amount of bump here. So let's maybe put this on 0.1 or something. So now I have my bump here. Or maybe not that much, 0.05 or something. So like this, that's fine. All right, and now you can see what happened. You have your bumps here now on the same value basically as the roughness map here and the color map here. So that's what we created here. So, but here is a little problem basically, because when you move this slider here up, you can see that the noise values change. So, for example, here when I put it to 0.63, you can see that my top here has no blue color anymore, but it still is upwards, so it still got some values to displace it basically with the set position node. And the problem is, when I move these points upwards, they are of course on a different position then, and by this they gather different attribute values from their current position to display the color and so on. So that's just because I move the points around. So on this position, they have exactly this values from the noise field. And when I move them to a different position, they have this values from here in the noise field. So they are not really the same. They don't display the same value map here. But we can solve this problem by just gathering information from a different position in the node tree. So to do that, there is a capture attribute. So capture attribute node, and with this node you can capture attributes, as the name suggests, on certain points in the tree. So for example, I want to gather information before I change the position. So I put it in between here. So now here my attribute is stored basically. And which attribute I want to gather? So let's say I want to gather this attribute here from the multiply node, before I put it in the vector. And when I now use this attribute output instead of the direct output here, so let's go here back, you can see it here pretty well. In this case, it's a bit on the wrong node because the value here is pretty low. So let's directly gather it from the color ramp itself, like this. So now basically the value here from the noise field, maybe let's just tidy it up a bit like this. So now my values for the noise field come directly out of the color ramp, then move in that capture attribute here. It stores the attribute from the color ramp in its normal position basically, because the set position is afterwards that. But the attribute is already captured here and stored, and then bypassed here. It's bypassing the set position directly in the group output. And that's why it's working now, because I'm gathering the information here on the color ramp before I change its position, then save it here, then I bypass the set position, and because of that, it doesn't matter where the points are there. Then you see that it's always like this. So the points don't change its values anymore, although they are moved up and down. So let's put that here, for example, like this, on 1.3, 0.13 or something. And now you can see what we have created. So let's maybe push this a bit to the side. So now this is a construct of the multi-usage of a noise field value, for example. At first we created the general noise field, and then we used that here for a movement, basically set position. So we moved the points up and down depending on their values on the points itself. And then the order is a bit different as we did it, but for the overview, we set the different position for the points. Then we used the attribute here, bypassing the set position. Let's change it here to the shader editor, that we can use it here as the noise value output and use it here for the attribute, the noise value input, and use the factor of it, so the grayscale from black to white, to mix two colors here, for example, red for the low values and blue for the high values. And in addition to that, we use this as a roughness map with the low roughness, which means glossy, at the red area here, and the very high roughness areas at the blue areas here. And with all of these combinations, we created this, I don't know, alien-like or virus-looking like thing with a procedural method, basically. And the cool thing about this is, and the reason you're doing this is, now you can just change the noise texture, because everything is based off of this noise texture. You can see that every branch is going off and going in there and coming in here, here, and here, and everything is starting basically here on this noise texture. And because of that, you can now change here the scale, for example, or move it, with a, let's use a vector math here, like I showed you in a video before, with the position as the input. Now you can move this map here to create this motion here, and everything moves automatically. So the height changes automatically, the color changes automatically, the roughness changes automatically, and you can add infinite and unlimited amounts of other different values which change automatically when you move something on the noise texture. So this is again the procedural method to create complex animations or shapes with a very low input effort after you build the tree. For example, now I have only to change this noise texture here to change a lot of different points here and in different aspects: color, roughness, position, and so on. Yeah, so that's how you could build something like this, a bit more elaborate, but in this case it's a very important lecture because here we come into creating a bit more complex shapes and animations with these procedural methods where you can create very nice geometry animations like this, with very low input afterwards, and then you can create a lot of different variations of it, since, as I already told you, since you got the tree now, you can create 100 variations of this in minutes or hours, and then you have 100 different shapes of this tree basically, where you can adjust these many values with a very low input that we humans can process it and understand it more easily. That's all for this video. Thank you and see you at the next one.